Hello again. This last video that I did, the episode 7, I've changed the title a bit to "Crap, skip if you want," because this video is pretty bad. At the start of the video, I explain how I lost the video file because I was an idiot, and then I go through what I did in poor detail, and then execute some stuff to show you how to do bits and pieces. And it's a really bad video. I've got to be honest. I'm not happy with it, and it's really long, 30 minutes. So I've put it as crap skip if you want. There is some information in there that's okay, but yeah, we're going to go through most of the things that were set up apart from the projection and view in the next couple of videos. And they're going to be shorter as well because these have been too long. So enough about that. I recently found this Anton's Opengl 4 tutorials, and I bought the book because he's got an ebook, which I got on Amazon. Let's find it on Amazon quick. Be on my orders. Ignore my orders. Yeah, this book here, Anton's Opengl for tutorials. There's a £6, well, £7 Kindle edition. It's really good. And there's free resources anyway online from him, but the book is good. So if you want to have a little look at that, you can. But the online tutorials, you've got triangle, shaders, vertex buffers, all the bits we've done apart from race-based object picking and stuff, and it goes down to compute shaders later on. And I'll do a little bit on that in this video because it's really interesting. But he also has his source code. So if you go to the source code on GitHub, you've got every single chapter, I suppose, in the book, which is really handy. And you can go into any one of these. Let's go into one that's not too complicated. Let's go into ray picking. And we've got make files and stuff in here because he does recommend to use make files and that, but you don't necessarily need to. You can build these using the tutorial to set up the window that I've made and the shaders, and from that point you can literally do anything of these using the main CPP. If you read through, you can see how he's done things, take it apart, do what you want with it. And that's a good way of learning. That's the way I've been learning to do compute shaders. And also, he's also in every single main he includes a utils CPP, which is just little functions that he's made to make his life easier that he's done in the tutorials previous. So the book's pretty good, and the stuff that he's got is really good. Now, quick thing about compute shaders, because they're really cool. I don't know too much about them, but it'll give you a better idea of why we're using this layout, the shaders and stuff. So for every we've got, at the moment we've got two shaders. We've got the vertex shader and the fragment shader, and basically every single vertex in the scene, for every single vertex in the scene, the vertex shader is used. So you imagine that's a lot of times that it goes through that code. And basically, if you were to do this on the PC, you can only run about a couple of these in parallel, like 8 or something. I can't remember off the top of my head. You can't run as many basically, but the GPU is built with lots of mini processors that are designed to run in parallel, so you can run, no matter how many vertices you've got, it will try and run as many of these files in parallel at the same time, which is why it's so fast, why we're getting like 60 frames per second easily with this little function. In fact, if you turn off your VSync, you'll probably end up with something like 500 frames per second if you've got a good GPU. And so yeah, every single time, so for every single vertex, this vertex shader is being used. And the fragment is basically every pixel-sized piece of space on the screen, but in 3D space. And so that sounds like it's a lot, but it's basically anything that's been drawn that gets passed through to the fragment shader if it's available from the vertex shader. So it's not too complicated, and there's culling and stuff that makes it so that you don't call this for the fragment if it's not actually been seen. So don't think of it as too crazy, but it does mean that for every single pixel on screen, so the higher resolution you've got, this is being called for every single point in space that has a vertex. Well, not vertex as such, but the area that the vertex array is built and stuff like that, God, I'm not really explaining it that well, and my knowledge on this is pretty basic as well. So, but that's the way I understand it. And now, so you can see how that kind of functionality, running that many things in parallel, is important. That's why they introduced compute shaders, a few years ago now. But compute shaders basically means that any float point calculations that we've got that we can run for particles or drawing to images, for example, like whilst we're running, anything that basically changes float point functions. I mean, you can do more than that, but it's basically general programming on the GPU rather than using the CPU. So we've got lots of data that can run in parallel, and that's the reason you want to use compute shaders. So, for example, on my project at the moment, there's I've got a compute shader running for every single fragment, basically every single pixel on a texture, to draw a ray to see if it's colliding with a sphere. So it's basically ray tracing a sphere. So you can see why the compute shaders will be important and why we want this kind of functionality available to us. But enough on that, because that's quite advanced for what we're doing at the moment. But it's just to give you an idea of why we want this functionality. So what we're going to do in this video, very quickly, we're going to clean up the uniform stuff because I don't like it. The way we've got it in this is really all over the place. It's the way I learned to do it, and now that I know a better way of doing it, I feel like it's best to show you. So we're going to clean up the uniform shaders, and I think that'll probably do for this video because I want it to be nice and short. And then in the next video, we'll actually start setting up some inputs so that we can have the mouse and keyboard controlling a camera. But we won't actually have it functional properly in that video. We'll just have it so that it's set up so that the keybinds work. And then we'll finally, in the video after that, we'll probably set up the camera so that we've actually got 3D movement in the space. And we'll probably change the creation of our vertices and stuff, our objects. This will probably be changed to a box, so we can just quickly scale it to make walls and floors and stuff like that, and we can just redraw the same object in different places. We could even, I probably won't do it in these videos, but we could even draw it in different colors and stuff. In fact, that wouldn't be too hard to implement, so we might as well do that. And yeah, actually I will do that because that'll be a good way of showing you how to use uniform stuff in another way. So in the last video that you may not have seen, depending on if you skipped it or not, the uniform projection and uniform view are the only parts that are important. And the reason they're important is because the way that you set them up basically defines the space that you're drawing to. So let me think, how am I going to do this? I'll tell you what, this video we'll just clean up the shaders, the uniform stuff, and then in the next video we'll go into the uniform projection and view stuff a bit more. Okay, so let's quickly clean this up. So basically we want the uniform location information to only be stored where we want it. So in this case we've got them in the main and we want them here only. And in the shader, if we go to the shader.h, we can see what we've got, all this information here, and we're basically duplicating it from here when we call it using the get uniform model or projection or view, which is, again, you're just making more functions that you don't really need. We're calling that to assign it in the while loop here. So you can see it's just getting bulky, really massive. Shouldn't be this crazy. So we're going to reassign the way that this works. Now the thing is, also we've got this in the while loop, and I don't think it necessarily needs to be unless you're using multiple shaders. I think we'll keep it in there for now because it makes more sense. We're going to change these parts, but we'll keep the uniform equals, and then we'll get the information from the shader class. We're just going to change the way that the shader class works. So first of all, we're going to get rid of all the uniform GLUints in the class. We're going to save that, and that's going to mean that these will come up in an error because they don't exist. Well, at least it should do, but it didn't. It's probably because they're still in the shader.cpp. So we'll go over to the shader.cpp, see where they're being initialized. Only there. That's strange. So we'll get rid of that. We don't want that initialized anymore. It's just the shader ID we want in the constructor. We'll go back over to the shader.h. There we go. Now they're showing up as Wrong, that's very strange. And we're going to take away all but one of these, and this one is going to be different. So we want to just get uniform location. We can get, and then we don't want to put the actual function in the class header. We'll put it in the shader.cpp, because we're not going to have a list of these here anymore, so we might as well move it. We're going to get rid of the pragma region because we don't need that, and then we're going to make the definition of the get uniform location in the shader.cpp. I'm glad I'm doing this today and not last night, because last night I could not focus. I tried doing it and I was like, this is a rubbish video, let's stop it and start again. So we've just created that function. I'm going to get rid of that because it's just, I keep opening it by accident. Just created that function in the shader.cpp and shader.h, and I've just realized that we're not actually getting anything, we're not passing anything in. So what we need to pass in is the string of the information that we need. And if we go over to shader.cpp, go into the compile part, down here we have uniform model equals get uniform location. These don't exist anymore, but we're still going to use this part. We're just passing it, we're just making it a function of itself rather than have to do it this way. So we can get rid of this entire section here by and yeah, so that's that part clean. So we just need to make the function now. Where have you gone? There we go, get shader information. So we need to pass in a constant car array, and we'll call this uniform string. I'm just going to put this in this bit as well. I should have done it before I created the function, but yeah. And then here we're going to have gluint uniform location equals, and then gl get uniform location. The shader ID, which we've already, which we will have set up once we've initialized the stuff. Otherwise, this will be 0. And anyway, yeah, I'll explain in a minute. Shader ID, and then we literally just pass in uniform string, and then we return the uniform location. So just before we return the uniform location, though, we want to make sure that we've got it. So we're just going to quickly go printf uniform, and then we send s for the uniform string, which we're going to put there in a sec. Location equals, and then send I for the gluint that we're going to put in, and then new line. So uniforms, right, from a uniform string and uniform location. Okay, so this is pretty straightforward. It's basically the %s is the string, the %i is the integer. So that's basically saying uniform this, which we're passing in a minute, and then uniform location is the location. So I'll explain that one in a minute. So now that we've done that, I think that means that this class is completely fixed. So we'll go over to the main, which I've called Opengl46fun because I'm silly. We've got these uniforms here, and we're going down to the while loop. Uniform model equals shader get uniform location, and then we just put in model because that's the uniform location we want. If we open up the vertex shader, uniform map4 model. Yeah, I hope we covered that in the video before last. Otherwise, some of this might be a bit alien to some of you, which will make it really bad because of the last video being so pants anyway. And then we're basically just going to do the same thing for the next bunch in here. So we're just going to copy this over and change the model to whatever we've got in here. So we've got projection, view, and space silly. I'll take out space silly once we've done it. So projection, uniform view is just a view. Uniform space silly is space silly. So that's basically doing the exact same thing, only we've got less code now. So if we want to add any more uniform variables to the shader, all we need to do is literally put it in the shader, add it to the list of gluints, and then get it and assign it as well. So it's still a little bit cumbersome to set up these uniform variables, but it's nowhere near as cumbersome as it was. If you think about it, we've only got to make this uniform variable up here now, rather than put it up there, put it in the shader GL UINTs, get the shader UINT, and also go into shader.cpp, and it was under the compile part where we were getting the uniform shaders down here and then printing out to the console that we're definitely getting. So we're just going to test this, make sure it works. It's going to come up with a load of lines saying where the locations are, because it's in the while loop, so it's just going to fill up. Yeah, there we go. Basically every single frame you're calling out that to get the information from the shader. Now that also seems a bit strange to me. It feels like we should only do this once. So let me think. I think because we've only got one shader at the moment, what I'm going to do is take the shader, and up here before the while loop we're going to have use shader, and then we're going to get the uniform locations, and we're just going to put them there. And this means that all that stuff won't be clogging up the console, but it also means we're only getting the information from the start. We can still see it's still using the uniform variables. I mean, we're still seeing it in 3D from the projection and the view and the model location. So it's definitely still working. The only problem is that if you've got multiple shaders now, you need a function that changes the shader and also reassigns the variables. So how would you do that in a sensible way is the question. I suppose that's for you to figure out. Anyway, how long is this video? 16 minutes, much better than normal. And I got to go into all the detail that I wanted to, which is really nice, and I didn't get all flustered with problems that I was running into, which is brilliant. So in the next video I'm going to set up the camera input handles, which will be using the window. So what we're going to have in the window initialization function, which is here, after we've set the window user pointer and the current context, we're going to have a function that we create that basically creates callbacks in GLFW, which is the library, and it's a bit strange because it takes a window. Well, GLFW takes the function rather than the actual what the function would return. So you know when you so for example, let's give an example. I'm just giving an example quick before we go into the next video. But so for example, let's see, something nice and simple. What can we use? So here, for example, although it's not calling just a function. Okay, GLFW get window should close, main window get window should close. When we pass in this information, we always expect the function to return a value, whereas this next part, for some reason, it takes in the entire function as a variable, and we don't put in the brackets. It's really strange. Anyway, I'll show you in the next video. Makes more sense. So we're going to set up, in the next video we'll set up key input and mouse input. So we've got the camera stuff. We won't do any printing because literally straight after we've done that, we're going to make the camera anyway, so we can see if it's working. But I think that should cover this video. I just pressed F12 by accident. I don't even know what that does. Very strange. Well, whatever that was, very strange. Anyway, I'll see you in the next video.